go through this. One flavor of that PMQPSK is called DP, or QPSK. So a representation of QPSK is it allows you to have 2 bits per signal, as opposed to the normal NRZ, which is just 1 bit per signal. This allows you to fit 20 gigabits in a 10 gigabaud signal. If you again think back to modems, then you can take this QPSK signal and you can polarize it, put it into two polarizations, 1 QPS signal per polarization, and it allows you to have 2 20 gigabit signals in a 10 gigabaud symbol. So you're able to fit 40 gigabits in about the same amplitude and phase as a 10 gigabit signal. One of the caveats of polarization mode is it requires some specific detection mechanisms that allow the receiver to detect the different polarizations. So it's a slightly more costly implementation. Another caveat is that it actually works better with higher dispersion. So one of the interesting, this goes back to when I mentioned that National LambdaRail runs on eLeaf, which is a low dispersion fiber. We also have built-in dispersion compensation units throughout the network to reduce dispersion, because the 10 gig signals that it was designed for work better with no dispersion. So in order to get the most benefit out of PMQPSK, we would have to remove the dispersion in the network. And even if we did that, the fact that we're on better eLeaf fiber actually can reduce the possible performance of the system. So here we have just a representation of older fiber. SMF has 17 picoseconds per nanometer per kilometer. And eLeaf is 4. So eLeaf, like I said, newer fiber, and that's what most of the fiber is based on. Actually, I think we have bits of True Wave Classic in our network as well. So it'll add some challenge and possibly restrict our distances a little bit, but that's yet to be determined. So now I get to talk about Cisco's implementation of 40 and 100 gig very briefly and generally. So DQPSK modulation in their 40 gig cards is shipping this month in release 9.2. We expect this, we know this should work alongside the 10 gig infrastructure that's there right now. Actually, Andrew had done some testing, which he's going to talk about in a little bit. Other caveat is that we'll have to include a guard band between these 10 gig and 40 gig waves. The size of that guard band may vary per route. We expect that Cisco will have a next-gen 40 gigabit CP-QPSK transponder out in the second half of 2010. This transponder should have the ability to reach 2,500 kilometers without DCUs. That's, again, if we remove the DCUs in the network. We're also probably going to analyze how that transponder will work with the DCUs still in the network, but that's to be determined still. Do I have any idea? Does Kevin have any idea? So do we have any idea whether we'll get better results or any results with the CP-QPSK 40 gig transponder if we keep the DCUs in the network?
No, we haven't done any.
Yeah. Right. And my Cisco limited statement on 100 gig is that they are working within the confines of the OIF standard for modulation for CP/QPSK modulation for 100 gig. I guess I can add one additional comment is that they believe it will be available when we're ready to start deploying for BTOP or ESNet. If we're ready to start deploying. Yeah, right. Stay optimistic. So this brings, because of the possible removal of the DCUs from the network and the two possible 40 gig options that we would be looking at, there's multiple ways of which we could deploy within the network, and we will probably be doing this on a case-by-case basis or a route-by-route basis, looking at busy routes and relocating 10 gig transponders in some areas where we think we want to migrate quicker to 40 or 100 gig down the road, or might look at other routes as to keeping, running the older 40 gig in parallel with the 10 gig with a guard band in between. This could be a monetary decision, could be a timing decision, could be a demand decision. So there's a lot up in the air as far as when we'll remove DCUs from what parts of the network. So we've done some testing or done some analyzing on NLR of the 40 gig cards that are shipping this month. Starlight to Washington can support 40 channels at 40 gig with no changes, but we would have to regen in Cleveland as opposed to be able to go all the way from Starlight to Washington. It would require a 300 gigahertz guard band between the 40 and 100 gig waves, which is basically two unused waves at 100 gigahertz spacing. Kansas to Starlight, no changes for 40 channels at 40 gig, but an extra regen in St. Louis. Kansas to Dallas, we actually will need to add a amplifier in Dallas in order to support 32 channels at 40 gig, but that's a pretty minimal change. Dallas to Houston, no changes. And Houston to Baton Rouge, no changes. If you're thinking, that's a kind of interesting selection of routes to look at first. Well, as you know, Supercomputing 2010 is going to be down in New Orleans, and we've had various queries about 40 gig and 100 gig to Supercomputing, and so we've begun looking at those routes first, primarily from Starlight down there.